Physics! It is the thing what does it when stuff happens. Blocky structures moving around, bumping into each other and breaking apart. The player having the tools to both build and destroy. That's the good stuff. I think survival block games in general are evolving to become more dynamic and interactive. Even Minecraft is taking steps to have a more physical sandbox through the Chaos Cubed update, as well as through mods like Valkyrian Skies and the recently released Create Aeronautics. The project I'm working on is no exception. Hi everyone, it's Wert. At Wert Software, we are building a next-gen voxel survival sandbox, the Rabbit Hole. Previously, I called out physics as one of the steeper remaining hurdles to cross before we have everything we need to build our dream game. Since then, I've been hard at work integrating physics into the Rabbit Hole. Creating a physics structure is easy. Simply throw any block into the world and get to work. You can push the block, you can drag it, stand on it, throw it around, and that's just the beginning. As soon as this block leaves your inventory, it becomes part of a new physics structure. This structure is basically its own voxel world, which means that, yes, you can both add and remove blocks. Removing blocks at places like this will even cause the structure to break in two. And you can have a lot of these. All of these cheese wheels are structures, just shrunk down. This opens the door to so much building potential. Think of all the crazy bases you can build this way. Take the house on a chain example from the previous video. Totally doable now. Think of all the crazy ships and platforms and bridges you can make. I'm thinking we could even add ropes and chains as physics joint objects, making things like rope bridges an option. We consider physics to be a fundamental feature, and we will be building a lot on top of this. The possibilities are endless. Getting here was neither simple nor straightforward. Those who saw the previous video might recall that I said we might be forced to build our own physics engine. It turns out that wasn't entirely true. Everything you've seen so far has been achieved through a modified version of the Avian physics engine. Avian, as is, doesn't quite meet all of our needs, but it's close, so nothing a little fork can't fix. We will maintain this fork to meet our wonky planetary domain-specific needs, and this is the strategy we will be sticking with for the time being. That being said, this solution isn't perfect. If it was, this video would have been out over a month ago. It scales pretty well and meets pretty much all of our design criteria for everything we want to use physics for, so what's the problem? Well, the problem is actually not with the physics itself, but with one of our other major design goals. I've previously called out Noita and Falling Sand Game as sources of inspiration. I find it very satisfying to see a grid behave like a fluid, and we strongly desire to see this kind of technology represented in the Rabbit Hole. What does this have to do with physics? I'm getting there. You see, computing where the block should be for this kind of cellular simulation is not too bad, even in 3D. But rendering, on the other hand, is a different story. The way the Rabbit Hole currently works is very similar to Minecraft. When it's time to load a chunk, the CPU lays out a mesh based on the voxel data, then sends it off to the GPU. Whenever something changes about a chunk, such as having blocks added or removed, the CPU rebuilds the entire mesh for that chunk and then sends it off again. If we were to simply apply cellular fluid logic and let her rip, we would create a traffic jam. With enough happening at once, a single update tick is not enough time for all of the work to get through, then the next update rolls around and there's just more work being added on, and so on until performance just grinds to a halt. There are a ton of different ways to solve this problem, but the one we are going to focus on for the purpose of this video is voxel ray tracing. Since voxels live in a uniform grid, you can just cast a bunch of rays into that grid to determine what's visible, then cast more rays to determine lighting, and boom, voxel ray tracing. The uniformity of the grid lets us take shortcuts to make this crazy fast, and since all of this is done on the GPU, you skip the part where the CPU sends a bunch of data over, eliminating the traffic jam. Just one problem. The rabbit hole wraps its voxels around a cube sphere, so the same uniform grid logic doesn't apply. Instead, we had to invent an equivalent non-Euclidean angular version of the same technique. We have a fully working prototype of this, which showcases how we can have large numbers of blocks rapidly updating without hitting a performance limitation. Okay, now we can talk about what this has to do with physics. Avian, the physics engine we are integrating with, as well as most physics engines for that matter, do most, if not all, of the work on the CPU. In this hypothetical, we just moved a bunch of our voxel ownership over to the GPU. So how are the CPU-resonant physics objects going to know where the water and sand blocks are if the GPU is shifting them around all the time? That's right, it's the same traffic jam again, but in reverse. Instead of the pipe getting flooded with CPU-updated meshes, the pipe is getting flooded with updates to sync the voxel data. Again, this is a problem that can be resolved in a number of ways or circumvented entirely, but for the purposes of this video, I want to focus on the craziest option. What if we take the physics and move it over to the GPU? This would mean abandoning Avian and implementing physics ourselves, but it would also mean that we could shoot for the next-gen stability that we wanted to get out of that AVBD research paper that I referenced in the previous video. It would also mean that we could achieve a substantially higher number of active physics objects. Your graphics card is really good at doing a bunch of tiny tasks in parallel, and AVBD outlines a path to handling physics in a parallel way. So, we built a series of prototypes. First, we ported the 2D CPU-based AVBD demo provided with the research paper to Bevy, which is the engine we've been working with. It works great. Then, we ported the 3D example as well. Again, works great. The stable joints and soft bodies in particular are very satisfying. This increased stability is what makes AVBD a next-gen physics solution and is what sets it apart from what pretty much every physics engine is doing. These prototypes gave us a pretty solid understanding of the math driving AVBD, so we were feeling confident. We then tried our absolute best to produce a GPU-native version. It didn't go so well. So we tried again. And again. Turns out, this is hard, and is probably out of scope for a team of our size. At least for now. While working on one of the drafts for this video, DimForge, the team behind the open-source Rust physics engine Rapier, announced that they are on track to start building a GPU-native version of their engine. In fact, they are even building new tools to make doing this type of work less of a pain in general. So, I'm not going to try to reinvent the wheel. I'm just going to wait for the open source community to reinvent the wheel for me. For the time being, the rabbit hole is going to stay on the CPU, as much as possible, and we will continue to use Avian to drive our physics. If and when any of the render work needs to get moved over to the GPU, we will just do a little song and dance to optimize what data gets synced and when. Gradually, we can shift more of the workload over to the GPU as more technology becomes available to us. In the background, I will continue to experiment with the GPU native port of Rapier and the tools that are being used to make it. This might not be goodbye AVBD so much as see you next time. All that and more will have to wait for a future video. I would like to apologize for the gap between the previous video and this one. In addition to the past couple months having a crazy number of developments that wound up directly impacting this story, I got into this just one more prototype mindset, and it did cost a lot of time, but I think that is just the consequence of making sure that we do this right. We are committed to delivering on the experience that we pitched, and I don't want to let you guys down. This means that sometimes, instead of picking a direction and going full steam ahead, we have to sample a few different options from the buffet to determine what we want for the main course. Regardless, we will be taking measures to improve communication in general going forward. We have a Discord server now. Join via the link in the description, and become a part of our small but growing community. YouTube comments are great for Q&A, and we will continue to read every comment. But Discord will make it easier to share ideas, art, music, inspiration sources, cool voxel stuff, and more. I will also be streaming again, once a week. The plan for now is that I will be streaming every Tuesday, usually around noon Eastern Time. I'll be playing through some of my gaming backlog and just kinda hanging out. It'll be chill, and if you catch me live, you're welcome to chat and ask questions. And if you happen to be watching this video within a few hours after upload, there is a good chance that I am actually streaming right now. Find me on Twitch or YouTube and come say hi. That is going to be it for now. If you made it this far, I'm sure I don't have to say that this has been a lot of work, but I'm going to say it anyway. Working on these updates and making this video has been a lot of work. We are a very small team, and I write and record and edit these videos myself, and that is on top of working on the video game. If you like what we're doing, or are at least curious and want to see more, you can show your appreciation by leaving a like, leaving a comment, interacting with all the buttons and stuff. BC and I read every comment and consider everything the community is saying carefully. If you are looking for a project where your voice will be heard and your suggestions can have a measurable impact, this is it. We welcome all comments, suggestions, and constructive criticism. Just keep in mind that everything you see is in a pre-alpha state and is a work in progress. Before you know it, we will be showcasing some truly incredible voxel technology, and you're not going to want to miss any of it. Assuming we stay on schedule, the next video you see should have something to do with the editing tools that you will get to use when the game ships. It's all really cool stuff that I'm super excited to show off as soon as it's ready, so make sure you're subscribed and join the Discord server to stay up to date. If you act now, you still might have a chance of being one of this channel's first 1,000 subscribers. And if you head over to the Over It Software channel, you might be able to be one of the first 100 subscribers over there. You can also follow both me and Over It Software on socials, and join the Over It Software Discord via links in the description. I'm Wert AC. This has been another Over It Sneak Peek. See you in the next one.